Okay, so so today our topic is now characteristics of hybridization. Any doubt with the hybridization concept?
No, no, sir.
No? Do I need to revise these definitions?
No, sir. We did this yesterday.
Is clear? Okay. I'm just
Yes.
simply telling you that hybridization means intermixing of atomic orbitals so that there will be a redistribution of energies will take place and you will get a new atomic orbital which are of same shape and same energy. Now, what are the characteristics of these hybridization? The first characteristics in hybridization, fully filled atomic orbital, half-filled atomic orbital, and empty orbital. All of them may take part in that particular hybridization. Okay. The total number of hybrid orbital formed is always equivalent to the sum of the atomic orbital which will take part in the process of hybridization. So whatever the number of atomic orbitals are there, same number of molecular orbital or same number of, you can say, hybridized orbital are going to be formed after the hybridization. Now, in order to calculate the total number of hybridized orbital which are going to be formed, the total number of hybrid orbital on the central atom of a molecule or an ion will be equal to the number of sigma bond plus lone pair, and which is known as steric number. Which is known as
Static number.
steric number. Okay, we will discuss this steric number in detail after a while. Okay, so this point I'm just simply moving, keeping it safe now for now. Next point is the one element can represent many hybridization state depending upon the experimental condition. Now, for example, suppose like atomic number. Atomic number for each and everyone is a constant thing. For carbon, atomic number is, what is the atomic number of carbon?
6, sir.
6. For nitrogen, it is 7. But in the
7.
case of hybridization, it is not a fixed entity that, for example, hybridization of carbon will be only sp or sp2. It depend upon the experimental conditions. It depend upon the nature of bonding, what it is making with the other element. So hybridization depend upon the opponent with which this particular atom is going to be combined. Okay, it
Yes, sir.
can be different. It can be sp, sp2, sp3, depending upon the opponent. It is more like a
Yes.
friendship. Now, depending upon the friend, we are having a friendship. If it is a very close friend, then we share differently. We talk differently to that particular person. Or if it is someone else, so it is totally different thing. So depending upon the other atom, that particular atom is going to show different hybridization. That is on the experimental condition. Clear?
Yes, sir.
The directional properties of hybrid atom is more than the atomic orbital. The hybrid atom is more directional. Therefore, the hybrid atomic orbital or the hybrid orbital are more stronger sigma bond. The
Sir, can you
directional,
say it again, sir? I didn't.
okay, the hybrid atom, the directional property. Now, if you
Yes,
remember
sir.
that p orbital is having a directional property that they are going to combine in a particular direction, overlapping will take place in a particular
Yes, sir.
direction.
Yes, sir.
So, more the directional
Yes.
property, which means more the stronger the sigma bond is. Okay, so hybrid orbitals, they have more directional property, so therefore they are going to form more stronger sigma bond,
Okay, sir.
okay, than that of the atomic orbital, normal unhybridized atomic orbital. Okay, the
Okay, sir.
directional property of different hybrid atomic orbitals will be the following order: sp, then sp2, sp3. Means more the hybridization is there, more the hybrid atomic orbitals are going to be included, more will be the directional property. Now in this s and p are there. Then sp2, 1s and 2p are there. 1s and 3p's are there. 1s, 3p and d is involved. sp3d2 is involved. sp3d3 is involved. Now, as you are going in this direction, that more the number of orbitals are involved in the hybridization, it means more the stronger will be the directional property and more the stronger sigma bond they are going to form. Clear?
Yes, sir. Yes.
The hybridized orbitals show axial overlapping and form sigma bond. Now, hybridized orbital, most of the time, what they are going to show, they are going to show sigma bonding, that is head-on
Sigma
collision.
bond, sir.
Okay, clear?
Yes, sir.
Next point is hybridization never takes place in an isolated atom, but it occurs only at the time of the
Sir,
bond
should we
formation.
We should. Okay, sir. Continue.
Uh, the next point is that hybridization is not a property of an isolated atom. Like for example, if suppose nitrogen is there or carbon is there, it will not hybridize automatically if it is isolated. Isolated means if it is not going to be reacted. Now, when carbon needs to form a bond with someone else, if suppose in this case, if you remember, beryllium is there. Now, beryllium itself is not going to hybridize all of its atomic orbital. When beryllium needs to make a bond with chlorine, then only it will form a hybridization. Otherwise, it is not going to do any kind of hybridization. Is
Okay,
that
sir.
the
Got
point
it.
clear? So,
Yes, sir. Got it.
hybridization will never take place in an isolated atom. It occurs only at the time of bond formation. Clear? And now tell me
Yes,
what you
sir.
were asking.
Nothing, sir. Got it.
Got it? Okay.
Yes.
Any doubt among these points?
No, sir.
Okay, ji. Chaliye. Now we will discuss about this point, uh, C and D point, that how it has been changed, how different, how a same element is going to show you different hybridization and what the exactly steric number is there. Okay. Now steric number. Now, if hybridization is coming, if you are calculating the number of total number of bond or steric number, if steric number is coming 2, then sp. If it is
Yes,
3, sp3. Sorry, sp2. If it is 4, sp3. Then if it is 5, sp3d. Then if it is sp3d2, 6, sp3d3, 7. So you have to remember this thing, these numbers. These are important. Okay?
okay, sir. Got it.
Okay, ji. Now see, CH4. Now CH4, we all know that CH4 means
Okay.
something like this.
Yes, sir. Well,
CH4. So how many elements are attached with the central carbon? Now this carbon is the central atom and these are the surrounding one. So number of atoms
four,
attached to
sir.
the center, 4 attached,
Yes, sir.
4. Is there any lone pair on the carbon? No, 0. So
No,
steric
sir.
number will
Yes.
be equal to 4. So hybridization will be equal to sp3. So this will be sp3 hybridized. Clear?
Okay. Got it.
Now it can be CHCl3 also. Again, total 1, 2, 3, 4. No lone pair, 4. NH3, 4. H2O. Now in the case of NH3, number of hydrogen attaches 3. 3
Yes, sir.
hydrogen. One lone pair is there. So 3 plus 1 is equal to 4. Clear?
Yes, sir. Got it.
Now in the case of water, 2 hydrogens are attached. 2. Lone pair are there on water, 2 lone pair. So 2. You have to take lone pair of central element, not the lone pair of other one. Okay?
Okay, sir. The center.
So 2 plus 2 again it is 4. Now
Four.
suppose you have AlCl3.
Yes, sir.
Now, aluminum is not having any lone pair, 0 lone pair, 3 chlorines are attached. So this is steric number is 3,
E.
means sp2.
SP2. Okay, sir. Got it.
Okay?
So the rest all are SP3, right?
Rest all are sp3. Now
Okay.
suppose this one CO2.
CO2, sir. Like two are like lone pair, right?
Now in
Yes,
this
sir. Two
number
are
of atom attached to, 2
atoms. The
atoms are
charge
attached.
is two. Yes, sir.
2 atoms are attached.
And
There is
yes,
no
sir.
lone pair.
And lone.
2 plus
Yes,
0
sir.
is equal to 2. So hybridization will be equal to sp.
SP. Okay.
Okay? Clear?
Yes, sir. Yes, sir.
Clear. Now we will see this compound. Now in those compounds, most of the time single element is there, one central element is there, and other are the surrounding element. Now suppose you are having this kind of compound in which 3 carbons are there. Now we have to find out the hybridization of each carbon, 1, 2, and 3.
Okay, sir.
Now first of all, we will talk about the first carbon. Now on first carbon, total number of elements attached, 1,
Two, sir.
2, and 3.
Three. Yes, sir.
Total 3 number of bonds are there.
Three.
We are not
Yes,
going to
sir.
include pi bonding. This is sigma
Yes,
and
sir.
this one
Got
is
it.
pi.
Yes,
Okay.
sir.
So 1, 2, and 3. No lone pair on carbon. So 3 plus 0 is equal to 3. sp2 हो गया. Okay.
Okay, sir.
Now second carbon. 1, 2, 3.
Two, three, three. So SP2.
Again sp2. Now
Yes.
what about the third carbon? 1,
So one.
2, 3, 4. 3 hydrogens
Yes,
are
sir.
there.
3 hydrogens.
It is
Yes,
like
yes,
this.
yes, 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 yes.
Clear? So one,
Yes, sir.
two, three, four. 4 means sp3.
3. Yes, sir.
So first and
3.
second carbon, which are attached with the double bond, they have sp2 hybridization,
SP2.
and the
Yes,
next
sir.
carbon is having sp3. Now I
SP3.
think the previous point is clear. Depending
Yes,
upon
sir.
the condition, one element can have more than two hybridization.
Yes, I got it.
Got it clear? Hai?
Yes, sir.
Now see this compound. C triple bond C H H. First hydrogen, second hydrogen. Now one, two. So for this two, it means sp. This is again one and two.
Yes, sir.
This is again sp. There is no lone pair on this carbon. So hybridization will be SNP, SNP. sp hybridized, sp hybridized. Is that clear?
Yes, I got it.
Pakka? Any doubt?
Yes, sir. So for 5, what was it again?
For 5? Okay,
Yes,
now
sir.
see. Now suppose PCl5.
Yes, sir.
So PCl5 phosphorus is making 5 bonds with the different
5.
different
Oh,
5
okay,
chlorine.
okay, yes,
So
sir.
5 plus 0 is equal to 5. Now for 5
Yes,
will be
sir.
sp3d.
Okay, sir. Got it.
IF7. 7 plus 0
7. Yes, sir.
sp3d3. NH4
Got it.
positive. So NH4 positive will be
So
equal
for
to
6, there is nothing.
no, it's for 6 it's there na
Okay.
sp3d2.
3D. Okay.
देखो, so first of all s and p are going to involve, so it means two
Yes, sir.
orbital. Then one s and two p are there.
Yes,
One
sir.
s and three
So
p.
SP.
Now after 3p, what is coming? D. So 3p D. Now D2 and D3. So up to this hybridization is taking place.
Okay, sir. Got it. So I didn't write it the table thing down. So,
Table thing. Okay. You have
so
this
I wrote it
PPT
now.
now.
I wrote it down.
You have this PPT now.
Oh, okay. Yes, sir. Yes.
No problem. Now, if there is a positive charge, then forget about it. No need to remember that. No need to do anything with this positive charge. Now,
Okay.
NH4 positive, nitrogen. Four hydrogens are there. Four. There is no lone pair now. So, four are there. sp3. Now, NH3 and NH4 positive. Both are having this kind of this thing. 3 plus 1, 4. 4. So, it means sp3. CH3 positive. 3 hydrogen plus then this carbon is having sp2 hybridization. Is that clear?
Yes, I got it.
ठीक है. Hajra, now this we have one, two, three, four, 5. Now quickly write down the hybridization of all of these 5 carbons in chat box. So ये क्या हुआ sp3. This carbon is 1, 2, 3.
SP2.
sp2,
SP2 again.
sp2,
Yes. And then
sp,
SP.
sp.
Yes.
ठीक है, clear?
Yes, yes, sir.
Okay जी. चलो. Now we will study about the different hybridization. ठीक है? How this is going to happen. Before that, we will study about the Lewis structures, how we can make structures. Okay, I forgot to teach this Lewis structures. So before that,
Yes.
just giving a pause to this hybridization case, we will discuss the first Lewis structure.
Yes.
Now, Lewis structures. Any idea about these Lewis structures? What are those? How are these made, or anything else about them? Any idea
So
about
I
them?
think is it the same thing as grade 10 one?
हाँ, grade 10 में जो whatever the things you guys have done in the grade 10 ना, it's
Yes, sir.
almost similar to this, but little bit of
Okay.
things are more. It's a little bit more, you can say, um, a little bit more
Like
difficult.
detailed.
Okay. हाँ,
Okay, sir.
okay. Now, Lewis was a scientist who gave a different structures for each and every compound, and these structures are based on the some energies. Now, what was the basic thing about that compound is that suppose hydrogen. Now, this hydrogen is having valence electrons, so it is more basically towards the valence number of electrons. Whatever the valence electrons are there, it will be given like that. Now, hydrogen is having one valence electron, or only one electron is there. So, hydrogen Lewis structure is like this. Helium, in the last shell, two electrons are there, so it will be He like this. Now sodium, if you take the electronic configuration is 281, in the last shell one electron is there, so sodium Lewis structure will be Na with one dot.
Hmm.
So in the Lewis structure, we are representing electrons in the form of a dot. Clear?
Yes, sir. Good. Yes, sir.
Okay. Now, similarly, in the case of chlorine, we are having 17 electrons. So 2, 8,
Yes,
and
sir.
7. So total 1, 2, 3, 4, 5, 6, and 7. So this is how we are going to show each and every individual atom's Lewis structure. Clear?
Okay, sir. Got it.
So in the case of Lewis structure, what we need to remember that
The
element
valence.
valence electrons have been
Yes,
represented
sir.
in the form of the dot. Valence electrons are
Yes,
represented
I
in the
got it.
form of the dot, and whenever the covalent bond is making, then sharing of electrons will take place. Like for example, if we discuss about the Cl2, so Cl2 will
Yes,
be
sir.
something like this: 1, 2, 3, 4, 5, 6, 7. Now
Yes,
another
sir.
chlorine: 1, 2, 3, 4, 5, 6, 7. So
Same thing.
you are going to make something like this. So this is
So we did this in grade 10, sir.
Cl10. You did this in
Yes,
grade 10?
yes, sir.
Okay. Just a second. Okay. Then suppose NH3. Now NH3, how we are going to make nitrogen?
Sir, nitrogen first, sir.
Atomic
Nitrogen
number
is
is 5.
seven,
Atomic number is 7.
seven,
Valence
seven.
electrons is
Yes,
7. So
yes, sir.
1, 2, 3,
Sir,
4, 5.
five, five. Yes, sir.
And 3 hydrogens we are putting it 1,
Yes,
1, 1.
sir.
And this making.
Yes,
Now this pair of electrons, they are not participating in the bond
yes,
formation.
sir.
So
Nothing
this
in
is
this,
known
sir.
as lone pair.
Don't touch this. Sir.
So lone pair are those pair of bonds which are not participating in the bond formation. Okay.
Yes, sir.
Now these pair of electrons, this is known as bond pair. Okay.
Yes, sir.
Clear?
Yes.
Similarly in water also, this is the lone pair and these are the bond pair. This is an easy one that we can easily make it. It's not a big deal. Now, if we have to make a complicated one, then what are those rules and regulations? Now, first of all, we will quickly go through those rules. Now, first rule is calculate the total number of total number of valence electron of the atoms present. Okay. If species is
Yes,
an
sir.
anion, add an electron equal to the charge. If it is a cation, subtract the electron equal to the charge. Now, suppose Cl negative. Now, Cl negative means one electron has been added. So total number of valence electron in this case will be 7 plus 1 is equal to 8 electrons are there. Got it clear?
Yes, sir. Clear.
Now suppose if I talk about the uh, Ca plus 1. Now in the valence electron, how many valence electrons should be there in this one? So calcium
Which
will have
one?
2 electron, but it is
Two.
plus
Yes, sir.
1. One has been
Yes,
lost,
sir.
so it is 1 electron is over there. So in the case of anion, you have to add the equal number of electrons to the charge. In the case of cation, subtract the equal number of electrons to the charge. Then you will get
Okay,
a
sir.
total number of electrons which are needed to be distributed. Now suppose if I give you the example of CO2. Now CO2 carbon, what is the valence of carbon? What is the
So
valence of
valence,
carbon?
so it's
4,
two, four. Yes, sir.
4,
2, 4. Yes.
6, 4, and one oxygen will have how many valence electron?
6. I mean, 2, 6.
Yeah, 2 comma 6 na?
6. Yes, sir.
6,
6.
6, 6. Now 2 are there, 6 into 6
Yes,
is
sir.
equal to 12.
Yes, sir. 32. I mean, 12. 6 into
12,
6 is 36, sir.
sorry, 6 plus 6, not into.
6. Okay.
12 na total 6
Yes,
electrons
sir.
into
12. 12. Yes, sir.
6
12.
valence 12, 12 plus 4,
Yes, sir.
16. So
16.
total we have 16 valence electron in the case of carbon dioxide.
Yes, sir.
So it means we have to distribute 16 electrons among this carbon, oxygen and oxygen. Clear?
Yes, sir. Got
Now,
it.
third point is select the central atom, which select the central atom. Now, we have to select the central atom. Now, for the central atom, the first of all, remember the atom which is supposed to be in the least number is supposed to be the central atom. Okay.
Yes, sir.
And second point, the which is supposed to be least electronegative element. Now, among the carbon and oxygen, we all know that carbon is the least electronegative
Yes,
element.
sir.
Okay. So, carbon is known as to be the central element. Clear?
Yes, sir. Yes, sir.
And
Got it.
remember, hydrogen and fluorine will always be at the terminal. Hydrogen can never be going to be a central element, and
Center
similarly,
element. Yes,
fluorine
sir.
is also not going to be a central element. They are going to be at the
Yes, sir.
terminal position because fluorine is the most electronegative one, so it cannot be a central one. Remember that central element will always be the little bit less electronegative.
So, sir, if both are same number of this thing, you have to use electronegativity and find them.
Yes, electronegativity and find them,
Okay,
or
sir.
most of the time we don't require to find this electronegativity wala concept.
Okay,
We
sir.
will do it
Yes, sir.
with the number of elements present. If the less number, now in this case automatically it is visible. CO2, one carbon, two hydrogen. So carbon is supposed to be at the
The
what?
middle.
Middle. Now if I say
Yes, sir. Center.
H2SO4, now
Yes, sir.
automatically sulfur is
S.
supposed to be the one
Yes, sir.
less amount number of. Okay.
Yes, sir.
Next
Got it.
point is put the shared pair of electron between the two atoms to represent the single bond. Now, agar single, if you have to represent single bond, this will be the single bond representation. Fine.
Yes,
Two
sir.
electrons. For double bond, it will be something like this. For triple bond, it will be six
So, yes, sir.
electrons,
6.
four electron, and two electrons for the single bond. So put one shade if one shade pair is there, single bond, two shade pair are there, double, and three shade pair are there, triple bond. So
Yes, sir.
put one shade pair of electron between every two atoms to represent a single bond between them. Then use the remaining electron either for the multiple bond or to show a lone pair.
Yes, sir.
Clear? So lone
Yes, I
pair
got
will
it.
always be there in the pairing. So we are going to keep this element, we are going to keep this electrons in the pair form. Keeping in mind about the octet of each and every element or atom is going to be completed. Okay, little bit confusing or
Yes,
little bit things are there, but it's not that you can say difficult. All these 4 points are clear.
yes, sir. Got it.
Pakka sure hai?
Yes, sir.
Chaliye. Now we will discuss about the CO, carbon monoxide. Now carbon atomic number is 6, valence electron will be 4, for
Yes,
oxygen
sir.
6. 6 plus 4
Yes,
is
sir.
equal to 10 valence electron.
10. Yes, sir. 10.
Okay ji. So first step is done. Calculate total number of valence electron of the atom. And second step, if it is an anion or cation, now we are not having any anion or cation, so no need to add or subtract anything else in this.
Yes, sir. We don't need to.
Clear?
Yes, sir.
Okay ji. Now we have to distribute these 10 electron between carbon and oxygen. Okay.
Okay, sir.
Now how we can distribute it? Now in this case, if you see 1, 2, 3, 4. Okay. Now first of all, carbon and oxygen, we are going to put one and one electron. Single bond electron we did. These two done. मैं इसको रेड से लिख देता हूँ. Now how many electrons left, beta?
Sir, 4, right?
4 electrons left? Nahin, 2 we have used na. So 8 electrons left now.
So we use only 2, right?
We used only 2. Out of
Okay,
10,
okay.
we have used
We
2.
use 2. Okay, sir.
So
Yes.
how many left?
8, sir.
8 left.
Yes, sir.
Okay. So next step was select the central element. Now put one shade pair of the electron in every two atom and represent single bond. Now use the remaining either for the multiple bond or to show the lone pair or valency. Now
Yes, sir. We're
put here
using
one,
like
one,
we put yes, sir.
two,
We put C as center.
3, 4, 5,
5,
6.
6. Yes, sir.
1, 2, 3, 4, 5, 6, 7, 8.
8. Yes, sir. 8
Total
others.
8
So it's
electrons
fulfilled. Yes, sir. It
fulfilled.
is.
How
Yes,
many
sir.
left now? 2 left.
2 left.
1,
So 1,
2.
2. Yes.
Now, this is the distribution of 10 electrons. 1,
Yes, sir.
2, 3, 4, 5, 6, 7, 8, 9, 10.
Yes, sir.
Now, if you see this carbon, octet is not complete now. 1, 2, 3, 4.
Yes, sir. Yes, sir. No.
नहीं बना, गड़बड़, problem है.
Yes, sir.
So electron should be distributed such that the octet of each and every element needs to be completed. So इसका
Okay, sir.
मतलब this structure cannot be existing.
Yes,
This
sir.
cannot be your
Don't
structure.
work.
पक्का? Sure?
Yes, sir. It won't.
Got it?
Yes, sir.
So I'm
Because
cleaning this. I am now clearing this now. So we have to draw a structure such that
both octet rule are complete.
ठीक है जी. Now suppose we make 2 double bond over there. ठीक है?
Okay,
In
sir.
this case, do we have anything?
So very true, sir. Yes, sir. We have
1, 2, 3,
2.
4,
Yes, sir. 4. Yes, sir.
5, 6, 7, 8,
7, 8. Yes, sir.
9, 10.
Yes, sir.
Now what about 1, 2, 3, 4, 5, 6?
So
Carbon
if you
again,
make a double bond with them, like
then again a problem.
yes, sir, it won't work.
Fine. Again, it can't happen. It is not possible.
Yes, sir, it won't.
1, 2, 3, 4, 5, 6, 7, 8 for carbon. 1, 2, 3, 4, 5, 6. For carbon, 8 electrons are not completed.
Yes, sir, it's not.
In this case, 1, 2, 3, 4, 5, 6, 7, 8 oxygen का तो पंगा ठीक है. It's clear. Not a big deal.
Okay,
Got it?
sir.
Clear?
Yes, sir. Got it.
Okay, ji.
Yes, sir,
So
got
it means again this structure is not clear. This structure is not correct.
Yes, sir, it's not.
Now, first of all, what we did, we put a single bond between carbon and oxygen. So
Yes,
one
sir, first
shared
we
pair
do
of
that.
electrons are there. Then again,
Yes, sir, we
then
know.
at that time, what happened? That carbon will not be able to get its all 8 electrons. Fine. So what we
Yes,
did,
sir.
we again put one more electron towards this one. We make it a double bond between them. Now, if we make double bond between the carbon and oxygen, again we will not be able to make it. Why? 1, 2, 3, 4, 5, 6.
3, 4, 5, 6.
4,
Yes,
5,
sir.
6
Like
electrons
it
are
won't
there,
be.
but carbon needs to require to have 8. Okay.
Yes, sir, we need 8 for.
So how we are going to complete this? Put one more electron,
So
triple
you
bond
can.
between them.
Okay, okay, got it. So if you put triple bond, it will work. Yes.
Now this triple bond is not the mutually shared bond. This is the pair of those electrons which are going to be exclusive sharing. Shared one. This will be exclusively shared, not the mutual shared.
Yes. Okay, sir.
Okay. Now see. 1, 2, 3, 4, 5, 6. 6. 1, 2,
So
3,
you need
4.
to make a triple bond.
1, 2, 3, 4, 5, 6, 7, 8. This is 8 electrons. For oxygen, it is good. Not a big deal.
It's
Clear?
fine. Yes, sir.
Now count total number of electrons 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total number of valence electrons we are having 10.
10. Yes, sir.
Clear? Hai? Fine.
Yes, sir.
Now we all know that carbon cannot have more than 4 electrons in the valence shell.
Yes,
Then
sir, we
what will
can't.
happen? This lone pair, this oxygen is
Yes, sir.
going to
Yes, sir.
give both of its electron and
To
make a
carbon.
bond.
Okay, okay. So like
And
a triple bond one.
this type of bond is known as a coordinate bond.
Okay.
Is that point clear? Yes or no?
Yes, sir. Clear. Coordinate
Sure.
bond. Yes, sir.
Got it clear? Do I need to repeat it
Yes, sir.
again?
No, sir.
Sure na?
Yes, sir.
ठीक है. Now coordinate bond will be always found from the more electronegative to less electronegative. Okay, so oxygen is the one which is supplying electron to carbon.
Yes, sir.
So the final structure will be
A triple bond with. Okay, got it, sir.
oxygen. Now 1, 2, 3, 4, 5, 6, 7, 8. Carbon complete है.
Yes, sir.
1, 2, 3, 4, 5, 6, 7, 8, 8 complete. Total number of electrons 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is supposed to be the best structure.
Okay, sir, got it.
Clear?
Yes, sir.
Any doubt?
Oh, sir.
Sure?
Yes, sir.
Okay जी. अब आ जाओ NO2 minus. What about this NO2 minus?
And nitrogen will have 5.
Nitrogen 5.
Yes, sir.
Oxygen will have
And
6. 6
oxygen
into
6
2,
plus
12.
12.
And
Yes, sir.
minus hai. Minus means one electron is
Minus
added
1
into it.
plus 1. Yes, sir.
So
18.
5 plus 12, 17 plus 1, total 18 electrons.
Yes, sir.
Okay ji. So it means we are now need to distribute these 18 electrons between the nitrogen and 2 oxygen. Okay?
Okay, sir.
Clear? Now between the
Yes.
nitrogen and oxygen, sorry, between the nitrogen and oxygen, which is supposed to be more electronegative?
Nitrogen, sir.
Nitrogen. Okay, just only 1 minute is there now. I will give you another link of meeting. Okay?
Okay, sir.
Okay.
Yes.
It will stop at any time. Fine. Okay, now nitrogen and oxygen. Nitrogen is supposed to be the more electronegative. So
Yes,
nitrogen
sir.
is going to be your central element,
Yes, sir.
and also nitrogen is in the least number. Repetition mein. Clear?
Yes, sir.
So in both the cases, nitrogen is our central element.
Sir, oxygen mostly never becomes center element.
Oxygen, fluorine are not supposed to be the central element
Okay.
because fluorine is the most electronegative and oxygen is the
Yes, sir.
second most. And nitrogen will only become in the case of when you are having fluorine with or oxygen with them. Okay?
Yes, sir.
And oxygen can also become a central element only if it is with the fluorine.
Yes.
So what we need to do now? We need to distribute these 18 electrons.
Yes, sir.
Okay. So these 80 electrons need to be distributed among nitrogen, oxygen, and nitrogen and among these two oxygen. And nitrogen is supposed to be the less electronegative, and it is also in the least number. So we are making it as a central element.
Yes,
Fine.
sir.
Okay, ji. So what was our now second step?
So you have to make
First of
everything
all,
like
make a
yes,
single
sir.
single bond between them.
Single,
So
single.
we are
Yes,
going
sir.
to follow the same step. We are going to make a single single bond between them. Now, when you make a single single bond, then again counting will be difficult.
Yes,
Okay,
sir.
you can try it by your own that how you are making it single single bond. Okay, then if okay, I will do it for you. Don't worry. एक हम लोग करके देखते हैं चलो यहाँ पे नाइट्रोजन
Yes, sir.
ऑक्सीजन ऑक्सीजन टोटल नंबर ऑफ इलेक्ट्रॉन्स मेरे को डिस्ट्रीब्यूट करने बेटा आई डिस्ट्रीब्यूट
18.
18 इलेक्ट्रॉन्स
18.
ओके
Yes, sir.
चलिए सो नाइट्रोजन 1 2 3
3,
4
4.
4
So
इलेक्ट्रॉन
single
डिस्ट्रीब्यूट
bond.
कर दिए
Yes,
मैंने
sir.
माइनस
Yes,
4
sir.
कितना बचा मेरे पास 14 इलेक्ट्रॉन्स आई हैव टू
14.
डिस्ट्रीब्यूट
Yes,
नाउ
sir.
ठीक है ऑक्सीजन 1 2 3 4
I.
फाइन
Yes, yes, sir.
1 2 3 4 1 2 3 4
4. Yes, sir. So
तो 4 एंड 4 8 कम कर
10,
दो इसमें से
8. Yes, sir.
तो ये कितने बच गए 4 एंड देन 4 10 10 10 minus 4 is equal to 6 electrons are there
6.
now
Yes, sir.
ठीक है
Yes.
नाइट्रोजन how many 5 electrons 1 now for this 1 2 3 4 5 6 नहीं बनी
Yes,
बात
sir.
1 2 3
Two
4 5
more.
6 but I have to
2.
distribute 6 more electrons now
6. Yes, sir.
I have 6 more
Oh.
electron
Yes, sir.
now first of all I will take with the nitrogen
Right.
so
Okay,
1
sir.
2 3 4
Yes, sir.
5
One,
6
two. Yes, sir. 6 only, right?
7 8
7, 8.
now if I do this thing now 1 2 3
4,
4
two are
5
left.
6 this one oxygen not completed this
Yes,
oxygen
sir.
octet not completed
Not
but
come.
what about
Yes.
this one 1 2
Night
3 4 5 6 7 8
completed. Yes, sir.
nitrogen octet is completed but rest
Yes,
two
sir.
octets are not complete it means this structure is not correct
Not correct. Yes.
ठीक है जी so what I will do खत्म करो भाई से I can't do this now
Wait, hold.
clear
We're not trying with double one, sir.
now we will try with the double bond so for that case what I will do एक सेकंड रुक जा जरा मेरे पास नाइट्रोजन का ये these two electrons है ना now what I will do I will take this electron over there
Okay, so it'll be double bond with one.
so one double bond will be there now
Yes, sir. One double bond.
चलिए now what we will do this one
So
now
one
for
double
this
bond.
oxygen 1 2 3 4 5 6 7 8
Yes, sir. It's
8
correct.
electrons are there. Complete है. For
Yes, sir.
nitrogen, 1 2 3 1 2 3 4 5 6 7 8.
Yes, sir. Complete.
Complete है. What about this one? 1 2 3 4 5 6 6.
So if you put two more, it will work, sir. Yes, sir.
क्या बेटा?
So like you can put two more, right?
Where?
Sir, we have 18 total, right?
18 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16
In 16. Yes, sir. Put
17
two. 18.
18.
Yes. Done, sir.
Done.
No, sir. No,
Or
sir. It won't work. It won't work, right?
na,
Because, yes, sir. It won't work because nitrogen will have more. So you have to put it in oxygen, yes, sir.
ऑक्सीजन पे पुट कर देंगे.
Yes, sir. Now it works.
क्लियर है. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. टोटल 18
Okay,
इलेक्ट्रॉन्स आ
thanks.
गए.
Yes, sir.
क्लियर.
It works. Yes, sir.
श्योर.
Yes,
अच्छा
sir.
एक बात बता बेटा. सपोज कर आई हैव गिवन दिस ऑक्सीजन नंबर 1, दिस ऑक्सीजन नंबर 2.
Yes,
क्लियर है.
sir.
फाइन.
Yes, sir.
नाउ think over a condition. Instead of giving this one and nitrogen double bond, this thing, can I draw like this also? If I flip the positions of 1 and 2.
Mhm.
एक second. Same concept, but this one is now 2, this one is now 1.
Yes, sir.
Both are
But
same or
nitrogen
different?
will not get fulfilled, right?
नाइट्रोजन पे अरे एक सेकंड रुक जा. ये आ गया ना नाइट्रोजन भी. सॉरी.
Yes, sir.
हाँ. Now what is there any difference between these two beta?
No, sir.
Yes or no?
No, no, sir. It will be the same, right?
Why?
So because both will have both are fulfilled, right?
Both are fulfilled.
Octets.
But if
Yes,
you
sir.
consider this oxygen as a 1, this oxygen as a 2,
Yes, sir.
between first oxygen and nitrogen, double bond is there. Between nitrogen and second oxygen, single bond.
Single
Now
bond,
here,
yes. In
positions have been
first.
twisted.
Yes, sir.
That is known as the resonance. What is
Okay, sir.
happening? This pi
Position.
bond, this is one sigma bond is formed. This one is your
Yes,
pi
sir.
bond, beta. Now this pi bond position is changed from one side to other side.
Yes, sir.
So this pi bond is shifting. Clear? Between the two
Yes, sir.
two atoms, pi bond shift हो रहा है.
Yes, sir.
भाई, this is more like a suppose करो. In our houses we generally, especially in the drawing room. Now suppose you have sofas towards the east wall. So what we did, we take those sofas and we move it to the west side of the wall. So what we have done, we have simply changed the position of sofas. Nothing has been done. Another thing, everything will remain same. Only positions of sofas have been changed. Similarly here, each and every distribution is not changed. Only position of your pi bond is changed. Clear?
Yes, sir. Got it.
That phenomena is known as resonance. We will study this later on. Is that point clear?
Yes, sir.
Resonance wala
Clear.
concept. So don't get confused whether the double bond is between the first two or this one. So this is that motion of pi bonding can takes place. That is known as resonance. Okay?
Okay, sir. Got it. Yes, sir.
Pakka? Sure hai?
Yes,
Any
sir.
doubt?
Yes.
So what will
Sure.
be its final structure? So this is the Lewis dot structure. So now we can draw it like this. Oxygen, double bond, nitrogen, single bond oxygen. Now draw the lone pair. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Now 1, 2, 3, 4, 5, 6, 7, 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And this total will have a negative charge. Clear?
Yes, sir. Yes, sir.
Fine.
Got it.
And
Yes, sir.
another structure we can draw it. Same thing can be there, but in a flipped manner. Now this thing, 1, 2, 3, 4, 5, 6. negative. So both answers are correct. If somebody is drawing like this, somebody is drawing like this, both are correct. Clear?
Okay, sir. Yes, sir.
Sure? Hai? Any doubt?
Yes, sir.
And
Yes,
these
sir.
two structures are known as the resonating structures. So resonating structures are those structures in which position of your pi bond is changed or different. Clear?
Yes, sir. Clear.
पक्का है? कोई डाउट इसके अंदर?
No, sir.
Sure?
Yes, sir.
Okay जी. चलो, now do one thing. This HCN, CO3 minus 2 or NO3 minus, try these by yourself as a homework.
Okay, sir.
ठीक है? इनको होमवर्क में
Yes.
ट्राई करना. और चलो एक और करके देखते हैं हम लोग. We will do one more and then we will do a concept of formal charge.
Okay, sir.
कौन सा करते हैं? इसमें करते हैं. We will do for the SO4. SO4 minus 2. करो. Quickly try to do it by yourself. एक बार करो मेरे
So 4 months.
फटाफट. Then I will guide you. 42 कैसे हो गए? Sulfur में how many electrons are
Yes,
there?
sir.
6
Six. Yes,
plus
sir. And
6 into 4
6 into 4. Yes, sir.
minus
24.
2 means plus 2 electron. So ये कितना हो गया?
32.
6 plus 24
32.
plus 2
Bouncing to 42.
32.
32. Yes.
So total
Sir,
32 electrons we need to
balance.
balance out, or we need to do it. Okay.
Yes, sir.
We need to distribute this one. So which one is supposed to be a central element?
Sulfur,
Sulfur,
sir. Yes.
oxygen, 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 oxygen.
Yes, sir.
ठीक है जी. Fine. First step is single bond, single bond.
Yes, I did that.
Very good. How many electrons are consumed in this
Sir,
case? 1,
8,
2,
sir.
3, 4.
8.
8 consumed.
8. Yes, sir. So
So minus
24
8
left.
करो तो कितना बना?
24.
24 electrons. Not
Yes,
24
sir.
electrons. Complete their valencies.
Yes, sir, I'm doing
So
good.
1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6.
Yes, sir.
6, 6 and 6, 12.
So I'm doing.
हो गया पूरा. हो गया बेटा. टेंशन ना ले. देख चेक कर. Do it, do it, do it. Check it out whether you are getting it or not.
Yes, sir. We put 6 in
So
each.
6 into 4, 24. And what
24,
about the
yes, sir.
sulfur? 1, 2, 3, 4, 5, 6, 7, 8.
We got all our equals, yes, sir.
Tha. Oxygen, 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 oxygen. And make it out as minus
Minus 2.
2. Clear?
Yes, sir. Got it.
पक्का?
Yes, sir.
कोई डाउट इसमें?
No, sir.
ओके जी. नाउ एक ट्राई करना H2SO4 और उससे पहले ट्राई करते हैं हम लोग HNO2 HNO2
So
sorry not
which,
minus
so which
HNO2
one first?
HNO2 HNO2 HNO2
Okay, sir. Which one?
HNO2.
So 14, right? We have
Mm-hmm.
14.
Hydrogen 1, nitrogen
Yes,
पे
sir.
will have 5,
5.
oxygen will have 6 into 2.
12.
Hey, 14 कैसे हो गया?
No, no. I put 4.
12 plus 6 18 नहीं हो
17.
गया?
18, you say.
18 valence electrons are there ना?
Yes, sir. 18.
And which is supposed to be the middle one? Nitrogen.
Sir, nitrogen.
Oxygen. Oxygen. Clear?
Yes, sir. Yes, sir. Got it.
Now hydrogen, where you are going to place hydrogen?
So
You
I've
can
put
place
it
with
on
nitrogen
top.
also,
Yes,
or
sir.
you can place with the oxygen also.
I've
Now
put.
check it
Okay,
out which is supposed to be the best structure by doing all these
yes,
things.
sir.
Okay.
Yes, sir.
Now when you do it, you will find
Yeah, I think I got it, sir. Sir, what I did was, I put
In
H
same,
in the
that is the
left.
same thing.
No, sir, I got a little different, sir. I'll show you. So you put H in the left.
Hmm.
So then N in the middle.
Hmm.
So like on the bottom you
H
put
N.
N, yes, sir, and
Hmm.
O bottom I put,
Hmm.
and then O in the right also.
Hmm.
So I made double bond with oxygen monoxide, yes, sir.
Hmm.
So and then I put four this thing, yes.
This.
And then a single bond down,
Hmm.
and then I put six.
Hmm.
So then one single bond hydrogen.
Exactly. अब जरा in this case, what about nitrogen? 1, 2, 3, 4, 5, 6, 7, 8.
Yes, sir. Eight.
1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3,
Yes,
4,
sir.
5, 6, 7, 8.
17.
And 1,
Yes, sir.
2.
Yes, sir.
Now
It works.
it will work like this.
Yes, sir. Yes, sir.
Clear? Now there will be a slightly change in this one. What change we will going to have? Now this structure will is the correct one. We have a little bit a concept of formal charge over there
Okay.
that I will tell
What's
you
that?
that
Okay.
this formal charge we have to also check it out whether this is correct or not. Okay,
Yes,
we
sir.
will discuss about this formal charge now, how we can imply this formal charge in a particular these making of these structure. Fine.
Okay.
Okay. Now एक second रुक जरा. Hmm. This is one. Now we will discuss about the formal charge. Now formal charge formal charge on an atom on an atom in a molecule is the difference between number of valence electron of that atom in free state and number of electrons assigned to the atom in the Lewis structure, assuming that in each shared pair of electrons, assuming that in each shared pair of electron, the atom has one electron of its own. That atom has one electron of its own and lone pair on it belongs to it completely. So the main thing is that this is the definition what you have to write in your exam, but the formula is now formal charge is for the atom. It can be for the an atom in a molecule. Formal charge will be equal to total valence electron, okay,
Yes,
minus
sir.
total number of electrons lone pair minus lone pair, okay, minus 1 by 2 total number of shared electron, that
Yes,
is
sir.
bonding electron. So if you calculate all of these things, you will get formal charge. Okay, ji?
Yes,
Clear?
sir. Yes, sir.
Okay. Now do one thing. We have this structure now. We have two structures. First, and this one is the second structure which I made. Hmm?
Yes, sir.
Okay. First of all, we will do the formal charge for the O3 atom. Then we will go on. We will come on the our structure. Our structure. O3. O3 will be oxygen, double bond this, single bond this. एक बार हाँ. So now what will the lone pair? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. I will name these oxygen 1, 2, and 3. So what will be the first oxygen formal charge? Total number of valence electrons कितना होगा?
Yes, sir.
6.
4, 6, yes.
This is oxygen. 6 valence electron minus lone pair on this. 1 and 2 lone pair are there.
4.
Lone pair electrons. So we are talking about the electrons. So 1, 2, 3, 4.
Yes.
Clear? 4
So 2, sir.
minus bond pair electron. Bond pair electrons, how many bond pair? 1, 1, 2, 3, 4, 5, 6. Nice.
6.
We are talking about the first one. Na? 1, 2, 3, 4. 4. 4 divided by 2 will be equal to 2.
2, yes, sir.
और इसको अपने थोड़ा
So,
आसान कर देते हैं. लोन पेयर ऑफ इलेक्ट्रॉन हो गया माइनस हाफ ऑफ बॉन्ड्स. इसको
bond,
और
yes, sir.
इजी कर
That's
देते
easier,
हैं.
sir.
माइनस ऑफ half of bonds formed
So
और
0.
सिग्मा बॉन्ड फॉर्म्ड.
Yes, sir.
सिग्मा नहीं, कोई भी सॉरी. 2 बॉन्ड है ना, तो यानी इट विल बी 1. 2 bonds are formed, the 2. Sigma को बिठा दो. No need to bother sigma or pi. Both will be included. So sigma bond formed. Minus this. So minus 2. So this will be 0 formal charge. Yes
Yes,
or
sir.
no?
Yes,
What
sir.
about the second one? 6
Sir, 6. And then lone
minus
pair is
4
4, yes, sir.
minus 1, 2, 3.
Minus 3, yes, sir. Minus 1.
Minus 1 आ गया.
Yes, sir.
For third oxygen,
6,
6
6.
minus
Minus 4, 4.
6.
Oh, why
1,
6?
2, 3, 4,
Oh,
5, 6.
lone pair, yes, sir. Then minus 1.
Minus
1.
1.
So minus
Again
1.
minus 1. ठीक है?
Yes, sir.
Clear?
Yes, sir.
So 0. एक सेकंड. ये सेंट्रल था. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 हो गया ना इस पे. ये हमने गड़बड़ कर दिया.
The
There
center
should
one is second
center
one,
one
right?
should not have this ना. हाँ. So lone pair should be
The 2, sir.
2. So this will be plus 1 then.
Yes, sir. 1.
Okay. So
Yes, sir.
all of these oxygen will have different formal charges.
Yes, sir.
Clear? This will have 0 formal charge, plus 1, minus 1. Okay. Clear?
Sir. Yeah.
Fine. And for making a central element, the formal charge should be the least one. अब आ जाओ. Calculate these two formal charges for nitrogen. What will be the formal charge of nitrogen on the in this?
Sir, 2 the lone pairs.
Lone pair
So
इसमें
for
कुछ है
this one,
फिर नहीं, in this one there is no lone pair ना. So
see
नहीं.
nothing.
First of all, 5 valence electron
Yes, sir.
minus lone
5,
pair,
0.
0 lone pair.
Yes, sir.
और
And 4 bonds.
1, 2, 1, 2, 3, 4.
Yes, sir.
Minus
4.
4.
Minus 4. Yes, sir.
ये कितना आ गया? Plus 1.
Yes, sir. 1.
ठीक है. What about this one? 5
So 4. 5 minus.
minus 1. 1
Sir,
lone pair
minus
ना.
2, right?
हाँ लोन पे इलेक्ट्रॉन करते थे ना, -2, सॉरी सॉरी सॉरी, -2
-2, yes.
-1 2 3,
-3. Yes, sir.
जीरो लोन
0.
जीरो आ गया, तो
Yes, sir.
फॉर्मल चार्ज शुड बी लीस्ट, सो दिस इज द करेक्ट स्ट्रक्चर,
Okay, okay,
नॉट
got it,
दिस
sir.
वन. क्लियर?
So you have to take in which the formal charge is the least.
Yes.
Okay.
So we have to make those character in which the formal charge supposed to be the least one. Otherwise, beta, both structures can be same na. But
Yes, sir.
think over it. Nitrogen is making a bond with hydrogen, and here nitrogen is not making any bond with hydrogen.
Yes, sir,
So the
got it.
chemical property will be totally different. How these two compounds can be a same thing?
Yes, sir.
Clear na?
Yes, sir, got it.
Sure. So
Yes, sir.
this is why we are having a different things are there. Clear? Hai?
Yes, sir, clear.
Got it? Any doubt?
No, sir.
I think enough for today.
Okay, sir.
ठीक है, I will send you one sheet. Remind me. Okay, if you are not getting it by 2 o'clock, remind me that I will send you one sheet in which so many other examples of this is will be given. SO4 and all these things, formal charge and all. Clear?
Okay, sir. Okay.
Okay, chalo. And revise for this which chapter?
Pe- Periodic, I finish.
Periodic class third chapter revise कर फटाफट. ठीक है? चलो. Okay बेटा. Bye bye. Take care.
Bye, sir.
Bye bye.